So here we go with the last presentation of this fantastic virtual workshop. So are we ready to test in the test? Or this at least is the question that I would like to answer during this presentation. I'm Mauro Pravetoni from CERIS, National University of Singapore, and I had the pleasure to coordinate this fantastic exercise, International Bifacial Round Robin. The numbers of our round robin in brief: more than 72,000 kilometers of total travel distance, only 3 modules over 16 broken, 5 module manufacturers, 24 participant laboratories, of which 16 accredited for module plus 1, which has an accreditation for cells only, 4 non-accredited laboratories, 3 simulator manufacturers. Almost 2 years of total duration, and so far 27 reports issued, some amendments as well. This map that some of you may have already seen shows the circulation of the samples that starting from Singapore and headed back to Singapore. First measurements ended in April 2018, last measurement in December 2019. This is an overview of the testing samples. As said, 16 samples, 8 couples of homogeneous samples per type. You see there are 2 bifacial couples, so 4 bifacial modules, and the remaining, 4 monofacial modules, and the remaining 12 bifacial samples. Trying to cover most of the technologies available at the moment, and also different size, including therefore 60 cells, 72 cells with some half-cut samples. Now, before having a look at the results, there are 2 important questions to address, which are very relevant for a correct evaluation of the performance of the participants. The first question is the stability of the samples. This is particularly relevant. As you know, samples have been measured from the beginning to the end by all the participants, and it is important that the sample were stable, not to have a correct estimation of the performance of each laboratory. This slide presents just one example of how we analyze the stability of the sample. Each of the measured samples were measured at the beginning and at the end by the coordinated laboratory at CERIS. And for this particular one, you can see we observed a degradation in short circuit current of 0.9% and an equivalent degradation in maximum power of 0.9%. In order to get confirmation of possible degradation of the module, which goes beyond the intermediate precision of the measurements at CERIS, we did also a trend. We plotted the trend of the measurements of all the participants, and you can see here the trends. This is particularly the trend of group 1 participant. We will see group 1 are the most expert, considered to be the most expert participant laboratories. And as you see, almost a 1% degradation has been also observed in their measurement. Same analysis for all the modules gave an indication of the possible uncertainty contribution due to stability. It's important to notice that there's an intermediate precision which acts as a kind of a threshold. So 0.4% is the possible deviation that plus or minus 0.4, of course, that we may observe in the short circuit current Pmax over 1 year measurements on the same sample, just for changing in the equipment or in just the different environmental conditions. So all deviations that are beyond 0.4% are not really relevant, but deviations higher than 0.4% may actually be considered degradation of the module. So for all these numbers has been treated as uncertainty contribution for uniform uncertainty, so rectangular uncertainty contributions have been added, as you will see soon, in the uncertainty of the assigned value. Another important second aspect that should be addressed while doing the evaluation is the homogeneity of the samples.
In general, if different laboratories measure different samples and the different samples are compared, it is important that these samples are homogeneous. Actually, this was not strictly the case. This is not strictly the case in a round robin because all laboratories measure all the samples. But there was an exemption which is related to the spectroresponsivity of the modules. In fact, not all the laboratories are equipped to measure the spectroresponsivity at module level, but some don't measure the spectroresponsivity at all, and some other laboratories are able to measure only at cell level. In particular, for those laboratories, we had to provide small cells with the same spectroresponsivity and bill of material of big radars. So homogeneity of the small samples and the large area modules had to be checked. For one particular sample, this homogeneity check was not possible at the beginning of the round robin in the interest of time, so it was possible only at the end of the exercise, and unfortunately we realized that there was not homogeneity between the mini module and the large area module. You can see in the picture here, from the front side and from the rear side spectroresponsivity, that few laboratories reported significant absorption in the UV. And this is not due to their problem in measurements, but it is due to the fact that has been checked that the small sample had an absorptive encapsulant different from the large area module. So the laboratories that made these measurements have been notified of this effect and provided with the assigned values of the big modules so that they could apply whatever corrections they needed in their results.
Now let's come to the results, and to have a better picture of how performance was analyzed, it's important to have a quick overview of the divisioning groups of the participants. So the biggest division is on those who have ISO 17025 accreditation for either testing or few of them for calibration, and those that do not have any 17025 accreditation for module testing. Exception is CSIRO, who has 17025 accreditation for cell testing, but not for module testing, so it has been considered as a non-accredited laboratory anyway. The accredited laboratory has been divided in two groups. Group one is historical, those with more expertise, so they can be considered as a kind of a reference laboratories, and all the other accredited laboratories grouped in group two. Statistical design has been divided in two groups, which I named here as gate 1 and gate 2. So gate 1 referred to monofacial modules. In this case, the assigned value for each measurement, this could be the short circuit current or the VOC or the maximum power at STC or other measurements that have been requested to the participant, and the assigned value has been evaluated as the weighted average of the group 1 laboratories only. Standard deviation is the weighted standard deviation of group 1 laboratories, and the expanded uncertainty as a contribution coming from the weights, which is the reverse square of the uncertainty of each participant, and the uncertainty due to stability that we saw before. For the evaluation of the bifacial module instead, basically it has been created an extended group 1, which means all the participants grouped in group 1 plus all the other laboratories that were scoring satisfactory on monofacial modules, which means that they have similar performance of group 1 laboratories on monofacial modules. So this extended group 1 was the group from which the weighted average was taken for the assigned value and the standard deviation, and again the uncertainty of the assigned value. And the evaluation itself has been made by two parameters, the Z prime and the EN score. These are parameters that are well known by our laboratories that take frequent part to proficiency testing or interlaboratory comparisons. Basically, the Z prime score is deviation normalized to the standard deviation of the assigned value, while EN score is the deviation between laboratory measurement and the assigned value, normalized to the uncertainty of the assigned value, sum square to the uncertainty of the participant laboratory. Basically, the EN score tells how your result is consistent with your uncertainty declaration, and the Z prime score says how your result is consistent with the distribution of the other participants' results. And of course, there may be 4 cases. The very good one is where both the N score and Z prime score are satisfactory, and the very worst case is when both are unsatisfactory. These 2 parameters have been plotted on Youden plots on the 2 axes. So on the Youden plot, you can see each participant could see if their own measurements for that particular measure on all the modules were belonging to a satisfactory or target or out of the satisfactory target. In particular, if your if your results lay inside the green square, means that everything is satisfactory, so very good. If they lay in this yellow region, it means that the Z prime is okay, but the EN number is bad, which means that you should probably check your uncertainty declaration. If you are in these other yellow areas, this is the reverse side, so the EN number is okay, so your uncertainty is fine, but your result nevertheless is a little bit biased by the average or the distribution of the other participants. And of course, the worst case scenario where both EN score and Z prime are bad. So let us see the results. Let us start with the monofacial module. I'm just showing here the results in terms of the maximum power at STC for the monofacial and comparing with the maximum power measurements of the bifacial, which we will see in the remaining slides. So the Youden plots on the top. In this plot on the top left, you see only the group 1 participants. All the group 1 participants anonymized. Each participant in their own reports were allowed to see their own dots highlighted, so they know where they are, but they don't know each other laboratories, which laboratories is which dot. So the circle represents the group 1 laboratories, while the square is the group 2 laboratories, and the triangle is the group 3 laboratories. You can see here that although there are some outliers, if we consider all participants, the distribution of measurements is quite consistent, which means that at monofacial level, and this is also confirmed for the box and whisker plots here, where the blue is the group 1, the orange is group 2, and the gray is the group 3 distribution. So quite consistent, so not particular differences between the participants in measuring the monofacial modules. And this is also an analysis of the interquartile range of measurements for Pmax, so around 1.3% deviations in interquartile range for group 1, while in general between 0.8 and 2, so pretty much consistent. For what concerns bifacial, here I'm showing the front side that measured at 1000 watt per square meter and the rear side at 1000 watt per square meter before having a look at the bifaciality. Again, quite consistent, although, and this is quite surprising. I mean, it seems that it's a good result for the community, because that means that the standard is well applicable with some reproducibility, and the reproducibility observed by the most expert laboratories is basically the same, with some exceptions on all the other laboratories. This is true for the front side, is less evident from the rear side. Oh, hang on, just before moving to the rear side, just to specify, these 4 modules are p-type modules, these 4 modules are n-type modules, and this is an heterojunction which shows us that non-significant problems have been, or at least the problem related to heterojunction measurement were well addressed by the participants and the multi-crystalline silicon module. As anticipated, a little bit more problem observed in the rear in the measurement of the rear side of bifacial modules. Again, the distribution of participants is not that different, although the spread now is a little more evident than before between group 1 and the other, all participants, but definitely the interquartile range in this case is slightly larger. And the reason may be that the rear side module is probably more difficult to measure. One possibility is what is shown in this chart here. There are obstacles behind the modules, the junction box, sometimes covered cells, so different laboratories may have had different procedure to avoid measurement artifacts. Not to count the case of bifacial modules with frame, for which the rear side can be measured at different position from the reference if there is no particular artifact avoiding or measurement corrections, specific corrections to address this point. Coming to the bifaciality, of course, the higher spread between all laboratories with respect to what measured by the group 1 may reflect the difficulties in measuring the rear side module. This is only partially reflected for the Pmax BF 100, which gives us an indication of the good approach used by the participants in addressing this new measurement. By Pmax BF 100 is the measurement where we are assuming 1000 watt per square meter on the front side and 100 watt per square meter on the rear side, which is by almost all the laboratories apart from 3 cases had been measured with a single source method, so with the equivalent ingredients method. And this is the case of BF 200. Again, there was an outlier participants, but then the distribution is quite equivalent. So in conclusion, let us have a look at the criticalities observed. So not particular difference or significant difference was observed between the groups. This is good news for the participants. 4 laboratories of group 2 and 3 rated satisfactory of monofacial modules. Evidence of more difficulties in bifacial in general was observed, and as expected, but not particularly technology related. The distribution between participants on the front for bifacial modules and monofacial modules is pretty much similar when we consider the front side measurement, while for the rear side some more outliers were observed. While in general only few outliers with respect of the general distribution of group 1 laboratories was observed on the BIFI 100 and BF 200 measurements. Unfortunately, not many participants measured with the 2-source meter or outdoors, so this particular challenging aspect of the exercise could not be fully addressed. And some differences was observed in the interpretation of the formula for the power gain yield, and so that the coordinator had to recalculate for most of the laboratories in order to be able to compare the results. And in conclusion, before raising to the acknowledgements, the anti-bifacial quiz. So you have 5 seconds to detect which one of these, A or B, is the front side of this N-type mini module. 5, 4, 3, 2, 1. Ta-da! Okay, A is the answer, and this shows a difficulty that some of the laboratories had in detecting, when measuring the spectroresponsivity of the mini modules, which one was the front side. Of course, one way is to measure the short circuit current when you get where the side which the highest ISC is most likely is the front side. But this was not done by most of the laboratories, and again, some laboratories swapped the 2 sides. So really, trying to keep the 20 minutes assigned, I really want to group my warm thanks to all the participants and the module manufacturer for this very exciting exercise. It would not be possible to do this in a reasonably short time without the very huge effort, not only of the module manufacturers, but also on all participants. So it was really a pleasure for me to coordinate this exercise. I hope there will be, it's not a one shot, there will be many events like this in the future, because I think that all of us really enjoyed this opportunity. So thank you again to the organizer Silvana and Chris, and please, I will be very happy to answer your questions.